All right. Good morning, Joel. I hope you had a great break. So I'm going to go through this pretty quickly. I'm going to have you do the practice problems on your own. So these two problems right here. So you're going to be learning about parallel and perpendicular lines, working with functions. And so first, let's kind of look at parallel lines. Looking at this and kind of follow along with my examples here as well. I'm going to zoom in a little bit on here. So the first way we can figure out if our lines are parallel is, of course, if we have two equations, we can graph these. And after we graph these, we will see that we will end up with a line. So plus 6, you're going to have a point right here. Let me kind of make it darker. And -4, you're going to have a point right here. And then you can go ahead and do your rise over run. So up to 1, 2 over 3, 1, 2, 3. And if you kind of see what's going to happen, up 2 over 3, 1, 2, 3, we're going to continue that process. And because they have the exact same slope, we're going to always have them going up and down at the same distance. And so they're never going to cross, which means they're going to be parallel lines. So one way we can see if parallel lines are parallel is by graphing them. Another way is that you might have a point and another line already. So y equals 1/2 x minus 7. And so what we can do if we are trying to make a parallel line to this line here, right? So this line here, what we can do is we can say, okay, well, if we know our slope is 1/2, and if you look at this example here in our graph, when we graphed these two lines and we had a slope of 2/3 and a slope of 2/3, it makes it so they never cross, right? So I'm hoping you're seeing that parallel lines will always have the same slope, but they have to have different y-intercepts, okay? So notice how over here, plus 6 and then -4, we had to have different y-intercepts. Otherwise, if they're the same, they're going to be right on top of each other, so it's just going to be the exact same line. So and we're trying to create a line that's parallel to y equals 1/2 x minus 7. What we can do is we can go ahead and use our equation. I taught you y minus y1 equals, and our slope is 1/2 x minus x1. Because we know our x, or our y1 and our x1, we can go ahead and plug those into our equation. So y minus 5 equals 1/2 x plus, I'm changing it to a plus because -2, a minus -2 is going to be a plus. We can go ahead and solve, right? And so distribute that 1/2 in, so you'll be left with y minus 5 equals 1/2 x plus 1. And then you can go ahead and do our solving linear equations, and you'll be left with y equals 1/2 x plus 6. And we know it's parallel because our slopes are the exact same and we have different y-intercepts. So our rule for parallel lines is that parallel lines have the same slope. Okay, if you have any questions with that, please let me know. But that's the biggest thing I need to teach you today about parallel lines. Go ahead and try this example here. And if you have any questions, let me know. Let's go ahead and go down to perpendicular lines. And so perpendicular lines are a little bit more difficult. So perpendicular lines, what's going to happen is it's going to create 90 degrees and it's going to cross at one point. And so let's go ahead and graph this and kind of see what's going to happen when we graph our two lines on a graph. So 1/2 x plus 3, so we're going to go up 3, put a point, and we're going to go up 1 over 2, and we can continue that process, up 1 over 2. And I think that's good. I think we'll cross there. We also have a line at y equals -2x plus 8, so up 8. And then we're going down 2 over 1, down 2 over 1, down 2 over 1. If you see, we're crossing right here. And so we know that it's perpendicular because we're crossing at one point and we're making two 90 degrees angles. So that's one way we can see if there's a perpendicular lines. And so let's kind of look at it if we had a question like this. Write an equation for a line that passes through 1 and -2 and a perpendicular to the line described. So by y equals 1/2 or 1/3 x plus 5, I might run out of time, so just watch the next video if I do. And so again, we can use our equation. And if you're kind of seeing what happened here, the difference between our slopes on perpendicular lines is that your bottom number becomes the top number and it becomes the opposite sign. So negative